High-voltage transformers are critical components in electrical substations, enabling efficient power transmission and distribution by stepping up or stepping down voltage levels. Below is a detailed explanation of HV transformers, including their functions, types, components, working principles, and selection criteria. Voltage transformation: step-up voltage for efficient long-distance transmission or step-down voltage for distribution to end users. Power transfer: transfer electrical energy between circuits without changing frequency. Isolation: provide electrical isolation between primary and secondary circuits for safety. Impedance matching: match impedance between different sections of the power system to minimize losses. Step-up transformers: increase voltage from the generator level, for example 11 kilovolts, to transmission levels like 132 kilovolts, 220 kilovolts, or even 400 kilovolts. Step-down transformers decrease voltage from transmission levels to distribution levels, such as 33 kilovolts, 11 kilovolts, or 415 volts. Auto transformers use a single winding for both primary and secondary, offering cost and space savings. Instrument transformers, current transformers, or CT, step-down high currents for measurement and protection. Voltage transformers, or VTs, step-down high voltages for measurement and protection.
Core, made of laminated silicon steel to minimize eddy current and hysteresis losses, provides a low reluctance path for magnetic flux. Windings: primary winding receives input power, secondary winding delivers output power, made of copper or aluminum conductors insulated to withstand high voltages.
Insulation uses materials like oil-impregnated paper, porcelain, and epoxy resin to prevent electrical breakdown. Transformer oil acts as an insulator and coolant. Common types include mineral oil and silicone oil. Bushings provide electrical connections between the transformer windings and external circuits, made of porcelain or composite materials. Tap changer adjusts the turns ratio to regulate output voltage. Types: on-load tap changer, or OLTC, and off-load tap changer, or DETC. Cooling system dissipates heat generated during operation. Common methods include oil natural air natural, or ONAN, and oil forced air forced, or OFAF. Conservator tank compensates for oil volume changes due to temperature variations. Buchholz relay detects internal faults like gas accumulation and triggers alarms or trips. Explosion vent releases pressure in case of internal faults to prevent transformer damage.
HV transformers operate on the principle of electromagnetic induction. An alternating current in the primary winding creates a magnetic flux in the core. The magnetic flux induces a voltage in the secondary winding. The voltage ratio between primary and secondary windings depends on the turns ratio. The ratio of primary voltage to secondary voltage is equal to the ratio of the number of turns in the primary winding to the number of turns in the secondary winding. Where primary voltage is V1, secondary voltage is V2, number of turns in primary winding is N1, and number of turns in secondary winding is N2. Voltage rating. Match the transformer's primary and secondary voltage ratings to the substation's requirements. Power rating, MVA. Ensure the transformer can handle the maximum load demand.
Transmission substations: step-up voltage for long-distance power transmission. Distribution substations: step-down voltage for local distribution. Industrial substations provide customized voltage levels for industrial loads. Renewable energy integration steps up voltage from solar or wind farms to grid levels.
Routine inspections include checking oil levels, bushings, and cooling systems. It's also important to monitor temperature and load conditions. Oil testing involves performing dissolved gas analysis, or DGA, to detect internal faults. Additionally, you should check the dielectric strength and moisture content.
Overloading can be managed by using transformers with adequate capacity and cooling systems. Faults can be addressed by installing protective devices like Buchholz relays and circuit breakers. Aging components should be regularly monitored and replaced. Environmental factors can be mitigated by using weatherproof designs for outdoor installations. HV transformers are the backbone of electrical substations, enabling efficient power transmission and distribution. Their design, selection, and maintenance are critical for ensuring reliable and safe operation. By understanding their components, working principles, and selection criteria, engineers can optimize transformer performance and extend their lifespan.